Finding the domain of composite functions is a tricky thing to idea to wrap your mind around. So I'm going to do my best to explain to you what this is trying to say here in blue. The domain of the composite function consists of inputs in the domain of G. That's a very important piece there. In the domain of G. So G is what's going into, that's your function that is going to receive inputs first. So the domain of f of G consists of inputs x in the domain of G, for which G of x is in the domain of f. Very confusing, right? So let me try and show you here. So this is what it's trying to say. I'm going to find the domain of G. So what x is allowed to go into G? Determine your x values that are allowed in G, okay? Then you're going to look at your f of G, or composite function. So then you're going to determine your x values that are allowed in f of G of x, okay? So in that composite function. So you're going to determine the domain of the composite function. And then your last step is you can't have, so your overall domain cannot include values, I'm going to make that one word, cannot include values restricted from number 1 above. So restricted from number 1. Okay, so if they were restricted, you cannot include those values in your overall domain of your composite function. So I'm going to show you a couple of examples, and one of them will most definitely be an example of that. So here I have f of x and g of x, and I want to find the domain of g of f of x. So we're going to find the domain of g of f of x. So my first step is to find the domain of f of x. So the domain of f of x is equal to, or is, so f of x, what can go in to x squared plus 1? Well, any real number, right? So all real numbers. So you can write that as all real numbers, or you can write it from negative infinity to positive infinity. That's the domain of f of x. Now we want to find, just like I said up here, now we want to find the x values that are allowed in the composite function. So I'm going to compute the composite function. We're going to have g of x squared plus 1. So the g function is a square root. So I'm going to have the square root of x squared plus 1. Well, no matter what I put in for x, whether it's positive, negative, rational, or irrational, I'm still going to get a positive number. So this right here is going to be a positive. And a positive plus 1 equals a positive number. And that's the only thing we need to worry about with that radical, is that whatever we put in for x, we result in a positive number. And that's going to happen no matter what because of the squared. So the domain of g of f of x is equal to, or is, I like the word is, again, all real numbers, or negative infinity to positive infinity. Therefore, our overall domain because one doesn't have more than the other, negative infinity to infinity. So you might be thinking, why can't we just go to number 2 then? Why is number 1 important? Why is it important? Why do we have to do this? So let me show you. This might say a trie, but I'm going to show you. So I want to do this one as an example to show you that that's not the case. So our first step is to find the domain of g of x. So the domain of g of x is 0 to infinity, right? Because you can only put in 0 or a positive number. So 0 to infinity would be allowed. Any negative numbers excluded from the domain. Then step 2. Well, what is f of g of x? F of g of x. F of g of x is the same thing as f of the square root of x. So I'm going to have the square root of x squared plus 1, which is just x plus 1. Well, the domain of f of g of x, or the result of f of g of x, right? The result of that is all real numbers. So it's negative infinity to positive infinity. But this is exactly what I was talking about. Well, you can't put negative numbers into your very first step. So your very first step is this step. This is your first step. These are your first inputs. So you can't just find the composite function and say, what's the domain of the composite function? Because this includes values not allowed in that first input. So in that first input, right there, there are values that aren't allowed. Therefore, we have to go back to 0 to infinity being our domain. I'm going to highlight this. 0 to infinity is our domain of f of g of x. So here's one that you could try, even though it says example. You can go ahead and try that one if you want and see what you get. So you might have to think about things a little bit because it looks very much the same, but it's not quite the same. Okay, so I'm going to start working it out. First thing I'm going to look at is my inputs that are allowed into f of x. So the domain of f is all real numbers. However, there are a couple of inputs that when I put in there, I'm going to end up with a negative value. So if I put a 0 in, 0 minus 1 is going to give me a negative value. And that's going to cause a problem with our composite function. So I'm going to come over here and I'm going to figure out what that composite function is. Well, that's going to be g of x squared minus 1. And that's the square root of x squared minus 1. Well, x squared minus 1 has to be greater than 0. It can equal 0, but it can't not be negative. So I'm going to have my critical values, negative 1 and positive 1. And then I'm going to test those values. When I put a negative 10 in, negative 10 squared is 100. 100 minus 1 is definitely greater than or equal to 0. So that gives me positive outputs. That's a check. That works. If I put a 0 in, 0 squared minus 1 is not, that's a negative output. That does not work. That is not greater than or equal to 0. If I put a positive 10 in, I get positive outputs, and that does work. If I put negative 1 in, negative 1 squared minus 1, negative 1 squared is 1, 1 minus 1 is 0, and that is allowed. So I'm going to close that dot in. And if I put a 1 in, that's allowed as well, because you can do the square root of 0. So I'm going to have a domain of negative infinity to negative 1, union with 1 to infinity. Now remember, the second one cannot contain more than the first one. So number 2 cannot have values that aren't in number 1. And they don't. All the values in number 2 can be found in number 1. Therefore, our domain is negative infinity, that's a parenthesis, negative infinity to negative 1, union with 1 to infinity. And that's our domain of our composite function. Now we've got a few more examples, one with an absolute value. And I think we're going to let that be a try. And I'm going to come back in the next video and work it out for you because it is an absolute value. In case you have questions, I'd like you to see the work.